All right, let's go over the review. I'll start. I don't know if this is being timed, but I'll try to go quickly through it. That way, if you need to speed it up, you can, or slow it down, you can. So I'm going to factor first here. Remember, finding the wholes is the common factors. So if we factor out a -1 here, this changes our sign, 6x plus 8, and then we can take out an x here, x minus 4. I can factor this further using the x method, and that is x minus 4 and x minus 2. Then we have x and x minus 4. So it looks like this is our common factor. Our simplified form is -1 times x minus 2 divided by x. And my common factor, set my common factor equal to 0, x equals 4. And to find the y value, we're going to plug that back into my simplified form. So we have 4 minus 2, that's 2, times -1 is -2 over 4, and that gives us -1/2. So our whole is 4 -1/2. All right, same thing for number 2. Can't factor the top, but I can factor the denominator. It would be plus 4 and minus 2 over x minus 2. Those are going to cancel. So my simplified form, if there's nothing on top, and just think there's one like this on the test, is a 1, right? So it's 1 divided by x plus 4. My common factor, set it equal to 0. So x equals 2. And to find my y value of my whole, we're going to plug it back in. So 2 plus 4, and we have 1 over 6. All right, number 3, factor out a 2 on the top, x plus 3. Factor out an x on the bottom, x plus 3. Those cancel, so my simplified form is 2 divided by x. And my common factor is x plus 3, so set that equal to 0. So the x value equals -3. And to find the y value, we're going to plug it back in to our simplified form, -3. So it's -2/3. All right. And then number 4. Let's factor an x out of the top first. So we have x minus 12, x squared minus x minus 12. We can factor out a -4 here. Move this to where you can see it. We have x squared plus 2. Oh, 4x. Good thing I'm writing with a pencil. 4x. All right, so I can factor the top one a little bit further. So we have x, I think it's -4 and +3. And then down here is -4x and x plus 2. So it looks like the only things that are in common are the x's. So my simplified form, if we FOIL that back out, is x squared minus x minus 12 and -4 times x plus 2. So set your common factor equal to 0. That's your x value. And then plug it back into your simplified form. 0 squared minus 0 minus 12 over -4 times 0 plus 2. So we have -12 over -8. So that would be a positive 6/4. Positive 3/2. 0 and 3/2. All right, and then number 5, let's factor this. So what multiplies to get 4 and adds to get 5? It's 4 and 1. Factor out a -2 on the bottom, and we get x squared plus x plus 2. Nope, it's going to switch the signs. Negative. All right, now I'm going to factor the bottom one more time. So we have x plus 4, x plus 1. And then on the bottom, -2, x minus 2, and x plus 1. So our common factor is x plus 1. Simplified form is x plus 4 divided by -2 over, or -2 times x minus 2. Set our common factor equal to 0. So it's x plus 1 equals 0, x equals -1. So my point is -1, and let's plug it back in here. -1 plus 4 divided by 2 times -1 minus 2. -1 plus 4 is 3. -1 minus 2 is -3 times -2 is +6. So 1/2 is our whole. Let's look at number 6. It's already factored. There's nothing else that I can factor out. So this one has no whole actually. So that would be your answer. Number 7, identify the holes, vertical asymptotes, horizontal asymptotes, domain, range of each. So our hole here, it doesn't look like we have one. This is written in A over X minus H plus K form. So we can use the fact that whatever H is 0 and K is -1. Our H value is our vertical asymptote and our K value is our horizontal asymptote. So our domain cannot equal 0 and our range cannot equal -1 because it matches our vertical and horizontal asymptotes. Okay, so then there's no holes because it's already factored the way that it is. So let's graph this guy. I'm going to use a pen just so we can see it. My vertical asymptote is at 0, so that's here. Horizontal asymptote is at -1. Let's find some points here. So I want to find some points that I can plug in for X that would make those values work. So I can plug in 3, -3, 1, and -1. Those would all work. So -3 divided by 3 minus 1, that's -1 minus 1 is -2. Now I'll plug in -3 over -3 minus 1, that's +1 minus 1 is 0. Now plug in 1, so -3, oh, let me scoot it up so you can see it better, divided by 1 minus 1, so -3 divided by 1 is -3 minus 1 is -4. And then -3 divided by -1 minus 1, that's +3 minus 1 is 2. So let's plot these points. 3, -2, -3, 0, 1, -4, and 2 on each side. That gives me a good number to know like what my smooth curve is going to look like, right? So it looks, really go through. So that's what it's going to look like. Yeah, on this one, for some reason, it doesn't tell you to find the intercepts. You can still do that, but it's not asking you to here. All right, so hole, again, we have none. Our H and our K here are 4 and 2. So that's going to determine our vertical and horizontal asymptote. Vertical asymptote is X equals +4, and horizontal asymptote is 2. Then our domain is X cannot equal 4, and our range is Y cannot equal 2. So let's graph our asymptotes first. X equals 4 is our vertical asymptote. Horizontal asymptote is 2. And let's find some values in here that would make this work for us. Let's see. 1 divided by something. Let's see, what could I plug in for 4? How about 3? And we could plug in, would 5 would work as well. What else could we plug in? Maybe a 2? That would make it 1/2, not too bad, but, and then we could also plug in 6. Let's try 6. All right, so we do -1 divided by 3 minus 4 plus 2. That's -1 over -1, which would be 1 plus 2 is 3. And then if you plug in 5, -1 divided by -5 minus, or sorry, 5 minus 4, that's 1. So -1 plus 2 is 1. And then if we plug in 2, -1 divided by 2 minus 4 plus 2, so that's Positive 1/2 plus 2 is 2.5, not too bad. And then 6 minus 4 plus 2, that's negative 1/2 plus 2 is 1.5. All right, so let's plot these. 3, 3, 5, 1, 2, 2.5 here, and 6, 1.5 here. All right, that's a good enough amount of points for me to figure out what that looks like. All right, looks good. A little bit to the other side. Okay, I'm not going to do these because these are taking a lot of time, but I am going to go down to these down here. So I'm going to pick just a few to do here. We're going to do the more difficult ones. How about 13? We need to find holes, vertical asymptotes, horizontal asymptotes, slant asymptotes, and domain. So let's look at our degrees here. That'll help us determine whether we have a horizontal or a slant asymptote. Your degree has to be one number greater on the top. And it's not, it's a 2 on the, it's a 1 on the top and a 2 on the bottom. So there is no slant asymptote. There is a horizontal asymptote because when it's bigger on bottom, it's 0. So y equals 0. The vertical asymptote, let's factor this and see what we get when we simplify. We can factor out a 3x. We get x plus 3. So if you notice, our simplified form here is 1 over 3x. So the one that we cancel is the whole, right? So to find the whole, we're going to set our common factor equal to 0. So the x value is -3. And then we're going to plug it back into the simplified form to find the y value, and it's 1 over -9 for the y value. My vertical asymptote is what could not cancel, so it's 3x equals 0, which means x equals 0 for my vertical asymptote. And our domain is the vertical asymptote and the whole, okay? I know some people were missing that on the quiz. It's -3 and 0, so it's the original denominator. So the domain is the original denominator set not equal to 0, okay? All right, let's graph it. We have a vertical asymptote at 0 and a horizontal asymptote at 0. We have no slant asymptote. X cannot equal those numbers, and we have a whole at 3, -1 over 9. So it's like right here. All right, so I'm just gonna draw a little curve right here because we know it's on this side and this side. If you want to do the table like we did on the other side, you can do that as well. All right, if we look at 14, if you notice that we have 1 greater on the top, so let me write these down. Whole, VA, HA, SA, and domain. All right, so we know that there's no horizontal asymptote because it's bigger on the top. However, because it's 1 greater on the top, it is a slant asymptote. So let's simplify this first, see if we can get some of this stuff out of here. I don't think so. X minus 1. Nope, nothing cancels. So we'll just divide it just like that. So we have -4x plus 4. And then x squared minus 3x, we're missing the constant, so we'll plug that in. -4 times what is 1? That would be -1/4. Oh, that's great. -1/4 times 4 is -1. -1/4 times -4 is +1. Changing the signs, so we get -2x plus 0. 4 times what is -4 times what is -2. That's going to be +1/2. 1/2 times 4 is 2. 1/2 times -4 is -2. Switch our signs, so that's positive, that's negative. negative 2. So this is our slant asymptote right here. Y equals 1/4 x plus 1/2. Vertical asymptote is the entire thing here. So it's going to be x equals 1 because we couldn't cancel anything. Our hole, we have no holes because we couldn't cancel anything. So our domain is x cannot equal 1. And the hole, but there's no hole. So that one doesn't count. So we have a vertical asymptote at x equals 1. All right, let's see our slant asymptote. Starts at positive 1/2. And we're gonna go down 1 over 1, 2, 3, 4. 1, 2, 3, 4. We can also go up and back, 2, 3, 4. It's bringing us back to our Algebra 1 days. We're constantly graphing linear functions. Okay, beautiful. We have no holes. I don't really know where to go with our numbers, so I'm going to figure out what numbers I can plug in here. How about 0? Let's see what happens when we plug in 0. You get 0 on the top and negative 4 times 0 plus 4. So 0, 0. Okay, so that helps me know where my graph is, like what side of the asymptote my graph is. So it looks like this. Kind of cool. All right, let's flip it to the other side. It says identify the horizontal or slant asymptote of each. So I'm looking at my degrees, right? If the degree is 1 bigger on top, 1 bigger on top. So if it's 1 bigger on top, that is an asymptote. So I got to do my long division here. So I got x squared minus 2x minus 8. Negative 4 times what is x squared? Man, we got a lot of like fractions here. It's not very nice. Negative 1/4 x times negative 4 is positive x squared. Going to cancel. Bring down our negative 2x. Negative 4x times what is negative 2? That's positive 1/2. I feel like it's the same as the last one. It's negative 2, and we get a 0. Okay. And that's a nothing. Okay, so our slant asymptote here is negative 1/4 x plus 1/2, and I just realized that I'm not writing in pencil anymore, so let me get my pencil back out. All right, let's look at this one. Our degrees are the same, so when the degrees are equal, you divide the coefficients. So when P of x is equal to Q of x, divide coefficients. So our coefficient is 1 over 1. So our horizontal asymptote is y equals 1. All right, next one, we have another one that is 1 degree larger. So we got to divide. We have negative 3x minus 6 divided by x squared minus x minus 2. Blah. Negative 3 times what is 1? So it's negative 1/3 x. 1/3 times negative 6 is positive 2x. And negative 1/3 times 3 is x squared. So we're going to change our signs. We get negative 3x minus 2. Negative 3 times what is negative 3? Positive 1. Okay, it turned out not to be so bad. So we have y equals negative 1/3 x plus 1 is your slant asymptote there. All right, let's see, number 18. It is 1 larger, so we have a slant asymptote again, negative 2x divided by x squared. Notice I'm missing a term here. So I gotta fill that in with a 0. Negative 2 times what is 1? Negative 1/2 x. Negative 1/2 x times negative 2 is positive x squared. Subtract, bring this down. What times 2x is 0? So my slant asymptote is negative 1/2 x. All right, so next, let's solve each equation. Remember to check extraneous solutions. I'm going to find my common denominator first. My common denominator is what they have in common plus what they don't. It looks like 3b is my common denominator. So let's see how we can get there. That doesn't need anything. My second term needs a 3, and my last term needs a b. So we got 3 and 4b cancels. So we have 1 equals 3 plus 4b. Can't be that easy, can it? -3, so -2 equals 4b. Divide b equals -1/2. All right, let's check this guy. Ew, gross. All right, this is 1 over 3 times -1/2. 1 over 1/2 and 4 over 3. What is, this is 3 times 1/2 is 3/2. If I multiply by the reciprocal, it's -2/3. 1 divided by -1/2 multiplied by the reciprocal, and we get -2 over 1 plus 4 over 3. Let's see what this is. 3, that should be 6 plus 4/3, -2/3. All right, so it checks out. So when you're doing your test, this is what you want to see. You want to see the work for the equation and then the check here. All right, let's move down to number 22, just for time's sake. So we got 3a, a, and 6a. So it's everything they have in common plus what they don't. They have an a in common. And then, like for the numbers, let's do a 6. So 6a is your common denominator. So we're going to multiply this one by a 2. 6a, 6a. The second guy needs a 6. And the third guy doesn't need anything, a minus 3. So distribute our 2 to a minus 4. 1 times 6 is 6. I can cancel out my denominators when I have the common denominator. So we have 2a minus 4 equals 6 plus a minus 3. Move our a's on the other side. Move our 4 on this side. So we have a equals 10 minus 3 is 7. All right, let's plug it back in. We get 7 minus 2 over 3 times 7 equals 1 over 7 plus 7 minus 3 over 6 times 7. 3 times 7 is 21. 5, 1 over 7, and that's 7 minus 3 is 4 over 42. I can reduce that to 21, right? And that's 2, and I can make this 21 by multiplying by 3, so that's 5 over 21 equals 5 over 21. That's just peachy. Okay, let's do a more difficult one. How about this one down here, number 23? Looks like we have some great amount of room to do this. I'm going to factor first. This is n minus 7 and n plus 2. Same thing over here. So common denominator is what they have in common plus what they don't. They all have an n minus 7. They don't, these two have an n minus 2, but this one doesn't. So it's going to be everything, n minus 7 and n plus 2. This guy already has both. So this n minus 7, n plus 2. This guy only has an n minus 7, but he needs an n plus 2. This guy already has everything as well. N minus 7, n plus 2. It's just a 1. We're going to distribute the 1. We get n plus 2. Once you get common denominators, you can cancel them out. Only in equations. 3 equals n plus 2 plus 1. I feel like this is just going to be super easy. Minus 3 and n equals 0. Okay. So we have 3 divided by 0 minus 14 equals 1 divided by 0 minus 7 plus 1 divided by 0 minus 14. So we have 3 over -14 equals 1 over negative 7 plus 1 over negative 14. So let's multiply this guy by 2. And we get 3 over negative 14. That works out. That is just fantastic. All right, let's flip it to the back. We got a few more questions here. All right. Let's do this guy up here. Factor first. I think I can factor out a 4. So that's 5n plus 4. Factor out a 4n squared. We get a 5n plus 4 here. Factor out an n, and we get a 5n plus 4. So my common denominator is everything they have in common plus what they don't. So I'm thinking 4 for sure, n squared, and 5n plus 4. All right, 4n squared, 5n plus 4. 4n squared, 5n plus 4. All right, so let's see what the first guy needs. It looks like the first term here needs an n squared. So it's 5n squared. The second term doesn't need anything. It already has everything. The third term needs another n and a 4. So 4n. All right, we got a common denominator. So we have 5n squared equals 1 plus 4n. I'm feeling alarms going off in my brain because we have to get everything on one side and factor. So I'm going to move the 4n over. 5n squared minus 4n and the 1 equal it to 0, and then factor this guy. So 5 times negative 1, negative 6. Nope, negative 5. Good thing I have my pencil. Negative 4. So what multiplies to get negative 5 and adds to get negative 4? All right, so I'm going to split my middle term. What did I say? Negative 5n plus n minus 1 equals 0. All right, factor by grouping. So we have 5n here, n minus 1, a 1, n minus 1. So we have 5n plus 1 and n minus 1 equals 0. Separate them and set them equal to 0. And solve. So n equals negative 1/5 and 1. All right, not too shabby. Let's go on to our work rate problems. So remember, it's 1 over A plus 1 over B equals 1 over T for team, right? So if one person can do a 1 job in this much time, this person can do 1 job in that much time. You add them together and you get the time together. So there's Angeli, that's an interesting name, and Jennifer. If they work together, how long? So 1 over 11 plus 1 over 10 equals 1 over x. I'm looking for my common denominator, which is going to be 110, okay. And x, sorry. So this guy needs a 10x, this guy needs an 11x, and this guy needs a 110. So we have 10x, 11x, 110, cancel my denominator, and we get 21, x equals 110. So 110 divided by 21 in your test, if you leave this like this, it is totally fine. Because you're not going to have a calculator, so let's just let fractions that look gross stay. It looks like all of these are pretty much the same. I will post a copy of the key in Canvas as well, but I hope this video has helped you with the graphing and the solving. So that will be there for you in Canvas, and I will see you soon.